On problem number 11, we're supposed to find an equation of the tangent line to the graph of f at the given point. And we're supposed to use the graphing utility to graph the function and its tangent line at the point and use the derivative feature of the graphing utility to confirm your results. We'll do part A of that together. We didn't really talk too much about using the graphing utility to do those, so we'll deal with that later. But let's find the equation of the tangent line. That's what I'd ask you to do on the test. If I want to find the equation of a line, we know from algebra that I need to know the slope of the line and I need to know at least one point that's on the line. Well, I know a point that's on the line. The problem tells me from number 11 that this is a point on the line. So what I need to know is what is the slope of the tangent line at that point? That's what the derivative tells us. Let's take the derivative of this function. F prime of x is equal to 3x squared. We know that's an easy derivative to take. So I want to know what is the slope of the tangent at -1, -2. So I'm just going to plug in that x value and find f prime of -1. Well, that'd be 3 times -1 squared. And of course, -1 squared is +1, and 3 times 1 is 3. So this means that I'm looking for a line that has a slope that's equal to 3 and goes through the point -1, -2. And the easy way to write that equation is just to use the point-slope formula that we learned in algebra. Y minus y1 equals m times x minus x1. And we'll just substitute in the three values that we found, and I can get y minus -2, which of course is the same thing as y plus 2, equals 3 times x minus -1, which is the same thing as x plus 1. And that's the point-slope version of the equation of that tangent line. And if I wanted the slope-intercept form, I could just distribute and subtract 2 from both sides, and I end up with y equals 3x plus 1 as the slope-intercept form of that line. Just one little variation. Sometimes, instead of giving you the x and y coordinate of the point, the problem may have just said at x equals -1. Then when I went to find the equation of the line, I would have only known the x coordinate, but I could still find that y coordinate. If I didn't know that the y coordinate was -2, I could figure that out by just finding out what is the value of f of x, the function f of x, at -1. So I could find f of -1, and that would be -1 cubed minus 1, which is -1 minus 1, which is -2. And that would then be my y coordinate of the point. So if they had only given me the x, I'd have to plug that x into the function to find the y coordinate and plug that x into the derivative to find the slope.